0 degrees.
The freezing point of water is either 273.15 Kelvin or we used to say what? Which is equals to 0 degrees Celsius. Next, is it all the different substance having the different boiling point or sorry, freezing point or same freezing point? Everyone. Different substances having different freezing point. So write it. Different liquids have different freezing points. Okay, so that is what you have to remember. Okay, guys, everybody. So now, you might be all experienced it in our daily life. You can see all of you. Now, presently, you are in summer, I think. So we are all, everybody is in summer. You can see outside temperature is very, very hot. Yes or no, guys? All of you. Now, if you see, always we want to prefer to have a soft cool drinks or cool water at least. So for that purpose, you can see we will put the water inside our deep freeze or normal freeze. Normal freeze, if you keep, it will become only cool. But if you put in deep freeze, what will happen, guys? All of you inside, what is there? What is the main reason? Inside liquid will freezes. So what is happening? When the temperature is lowered, all the particles will come closer or they will move far each other. All of you.
Come closer.
Yes. The temperature is lowered. So during the freezing, what is happening? All the particles are come closer. Understanding? Closer to one another, and they will turn into like a solid. So the force of attraction will increases or decreases. Everybody, they'll come into closer.
Increases.
The force of attraction comes into, and the particles will start packing very, very closely, and ultimately they will converting into what state? When they are coming closer each other, the force of attraction is the main role by the time, so that it will turns into what? Mr. Nivedan, Kishore? Solid state. It will turn into solid state. So that is the reason. So under normal conditions, what will happen? Under normal conditions of temperature and pressure, the melting point and freezing point of a substance, same or different? Everybody, all of you. Yes, please. Suppose. Same. Yeah, same. If I take the solid to liquid, what we used to call? Everybody. Solid to liquid, what we used to call? Melting. Now, liquid to solid, what we used to call? Everybody.
Freezing.
So, from that I can say, melting point of any substance is equals to freezing point. Is it okay, guys? Everybody? All of you? Yes, please. Understand, Ra? Yes, please. All of you? That is what we can say is that. So from this, we can make a statement. So what is the statement I can say? So the state of matter can be changed. State of matter can be changed. Or interconverted by changing the what, guys? From this we can prove that by changing the what? Something. By changing the temperature. Because we are studying presently effect of temperature only. Am I correct? Everybody? Yes? That is
Yes, sir.
Write it. Any doubt, ask me. So I can say for any substance, melting point is equals to freezing point and boiling point is equals to what?
Condensation point.
That is what. Make it.
Sure.
Yes. Over. So this is what it is over now. So we went to solid to liquid, liquid to gas, and we came back from liquid to solid, gas to liquid and liquid to solid. So this is what everything is over. Now, directly we have some substances directly converting from solid to gas or from directly converting from gases to solid. So that is only we used to called as last process. That is what we used to say. What is that process name called as? All of you?
Sublimation.
Sublimation.
Okay, so write it. Sublimation. Sublimation. So sublimation, one main word you have to use it. What is the main word? Without changing into what state? Without
Liquid state.
changing into
Liquid
liquid
state.
state. That is what. Write it. Definition. The process in which a solid directly converts into gaseous state on heating or vice versa. What do you mean by vice versa, everybody?
Reverse process.
Yeah, vice versa on, this is heating. Agalya, this is heating. So vice versa will take place or what? Vice versa on cooling. Understanding? Cooling without changing into what? Somebody should not form. What is that?
Liquid.
Liquid.
Liquid state is called sublimation. But reverse process, instead of sublimation, we can call it as what? Everybody? We can call it as a deposition. Okay. Solid directly converting into gas. We used to call it as what, guys? All of you. Sublimation. Okay. So sublimation. Next. That is only on heating, we can say. This is heating. Next. Reverse process also we can say sublimation, or we can say what? Everybody. Or we can say deposition. Okay, deposition. But this process is what? Everybody, cooling. But the main important one, what? Without forming.
Liquid.
Without forming liquid state. That is the very important one. Is it okay, guys? Everybody clear? Yes. Understand, Ara? So now, you take so many examples in our daily life. Okay, for example. Let me take, all of you remember now, two words also I will use. One is sublime. Another one is sublimate. What is that? One is sublime, another one is what? Sublimate. Okay, right. The solids which can show the sublimation, the solids which can show the sublimation is called, what is to call? Everybody, sublime. Enara, we used to call it as sublime. Okay, next. The solid obtained due to sublimation. Solid obtained due to sublimation. Sublimation means what? Obtaining the sublimation. Means what is that process? Everybody. Deposition is called sublimate. Is it okay, guys? Everybody? But both the meaning is same. Yes or no, Mr. Nivedan? Sublime or sublimate? Yes or no? Yes?
Yes, sir.
Yeah. So for example, you are all your home, you are having a camphor. Camphor terima. Your home you will be having a camphor. Yes? Dupam.
Yes,
We
sir.
can say. Dupam. So dupam you can see. So it's an example of sublimation. So if you put the fire, then what will happen? Without forming into the liquid, it will turn into gaseous state. Yes or no, guys? Camphor? Yes? Nobody?
Yes,
So,
sir.
which will show sublimation. You can take camphor if you are having iodine crystals. So iodine also will show the sublimation only. And if you are having a mint crystals, so mint crystals also will show sublimation only. If you are having a dry ice, what is a dry ice meaning? Anybody can tell me? Formed by what? Formed by condensing of what, guys?
Carbon dioxide.
Yeah, formed by
Carbon
sublimation
dioxide.
carbon dioxide. Dry ice we used to call as. Okay. Next, If you take ammonium chloride, that is also example. Ammonium chloride. Okay. Next. If you take naphthalene balls telima, we'll put it in toilet and all. Yes or no? Olden days, now also some people will put under the cloths and all, not to be affected by the cockroaches and all. Yes or no, guys? Everybody?
Yes,
Yes.
Yes, sir.
All are the examples of what? All are the examples of sublimate products. Is it okay, guys? Purima? All of you.
Yes, sir.
So let us perform the activity which is given in our book so that you can understand. You remember this many examples for sublimate products. Okay. So now you can see, I will teach you on real life science in life. Let us see that. Sir, where is the sublimation product will be helpful for us? It will be helpful. So where means, have you all knows that hard surfaces like mug, plates and all? Have you checked it? If you go to Janapriya, you can get the mugs with the different colors. If you go to any kind of Janapriya or if you go to Adigalam and all, wherever the stores, the plates and all which is printed with the beautiful designs. Anybody theriyuma? Adi ellame beautiful designs. Yes, please.
Yes, sir.
So the beautiful designs, like they are printing the something like a special dishes and all, and the printing itself, it will come attracting designs. Yes or no, ma? That's all the designs, these mugs, plates and all, how they are printing, they can be printed by the dye. The dye, whatever the color they are getting, actually that is what we used to call as, they can be printed. That is what you can be right. Can be printed, that is a science in life, by a dye sublimation. Dye sublimation printing, which is based on the principle of what? Which is based on principle of sublimation only. So whatever you are getting, the beautiful designs and all, everything they will print based upon this only. Okay, guys? Yeah, dyeing, Sanjay, exactly correct. Dye sublimation we used to call. Okay, so this is a science in real life. If you want, you can make the sublimation important. Now let us see that they have given one activity in our textbook for this sublimation. So let us discuss that. So that is only this one. So not this one, this one. So take some camphor and crush it and put it into the china dish. Put an inverted funnel over the china dish, but that funnel must be plastic one, glass one. Everybody, it must be, yes, one. Inverted funnel must be what? Actually, it must be the glass one. Okay, you should not take plastic one, it will melt. Okay, Lingesh, Kishore, Sam, that is
Yes, sir.
next. Put a cotton plug on the stem of the funnel as shown in the figure. This is what cotton plug. So what is the use of cotton plug? So that the fumes won't go out. Is it right or wrong, everybody? Yes or no? All of you? Now, so in china dish, I kept this is a china dish, I kept the camphor. Now you can see, if I keep on started heating, you can see, you take camphor or you take ammonium chloride, sir, only they are saying camphor, why, sir? Not only camphor, you take ammonium hydroxide, ammonium chloride or anything, whatever I told, so many examples. So if you started heating, what will happen? You can see that what do you infer from the above activity? So you can see slowly the fumes will rising up. Understand, everybody? The fumes, what fumes actually? That is what? Camphor vapor. What is the vapors, everybody? Camphor vapors. If I take ammonium chloride vapors. Now these vapors will rises up and they will go and will touch the walls of this inverted funnel. That is what? Walls of the inverted funnel. And here they do not have any escape to go outside because we kept the cotton plug. So these hot fumes will come and will touch this walls of the container, this funnel, and as well as this cotton plug, and the cotton will absorb the heat energy from it, so that again this all the camphor will be deposited on the walls of the container. Can you see it here? At the walls of the container it is depositing. Am I right or wrong, everybody? Yes, please. All of you, at the narrow end, you can see it will give the camphor or ammonium chloride. It will be condensing back at the walls of the container. Have you noticed it or not? Please respond, guys. Everybody. So that is what you can see. So here, we can, when we are heating the camphor, we can notice only the fumes, and again we can see directly solid on the walls of the funnel. So from this activity, we can make it. So the substances which can be converted from solid into gaseous, and from gaseous form into solid state directly. So that is why camphor, we can say what product it is. What is the name of the product? Camphor is called as, everybody, sublimate product. Okay, so that is what you have to remember it. Now see this one, the solid which is converting in the sun, converting into the gaseous state, which we used to called as what, everybody? We used to called as sublime.
Sublimation.
And the solid which is formed on the walls of the container. Actually, both are camphor only. Yes or no? Agalya, Shivani? Both are camphors only. But this camphor which is converted on the walls, what we used to call?
Sublimate.
Sublimate. That is why I'm saying sublimate and sublime both are same. Okay, guys? Everybody? So this is what you have to remember. So what is happening? We are observing that a change of state directly from solid to gas without changing into the liquid state is called as what process, everybody? Sublimation.
Sublimation.
Direct change of gas to solid without changing into the liquid is called as what, everybody?
Deposition.
But somebody's noise, I don't know who is that. Mr. Kishore, I think. Yeah, that is what deposition, or simply you can say that is also called as sublimation only. Okay, now you no need to study this pressure one. You can remember here is they mentioned about the pressure. So till here, effect of change of pressure, we people will start in tomorrow's class. So till here, everybody need to read all the things and you have to be ready for the tomorrow's class. Will you all do it or not, all of you? So till here, you have to read it. Okay, guys. Now, till
Yes,
here,
sir.
including this,
Yes, sir.
including this triangle also, if you want, you can read it. Interconversion of three states of matter. Now we are familiar, so that you can read. But this you can read it. I told you already. I taught you what is atmospheric pressure. One atmospheric pressure is equals to how much? Simply, no need even 1.01. Simply, I can say how many pascals, guys? 10 power 5 pascals. Equals to 1 atm. How many atms? 1 atm. Clear? 1 atm. Sea level is 1 atmosphere is called atmospheric pressure. So what is atmospheric pressure, everybody? ATMs. And what is the SI unit of pressure, everybody? SI unit of pressure, pascals. Okay, SI unit of pressure is pascal. So 1 atm is equals to how many pascals? 10 power 5 pascals, or 1.01 into 10 power 5 pascals. That is what you have to remember. ATM means atmospheric pressure. That is what you have to remember. Okay. Now, these questions also you have to solve it. I hope I already told you to solve. So you have to solve it. Okay. So now you can make it, everybody. Then from here, we will study tomorrow effects of change of pressure. So once effect of change of pressure is over, then we'll go with the direct concept called as, what is that concept? Evaporation. Okay, so hardly 2-3 days will complete this chapter, everybody. So with this, I will stop the today's class. Hope you are all clear. Anybody having any doubt, you can ask me, or else you can leave from the meeting. Thank you, everybody.
Thank you, sir.
Please complete the work. That is very important. Okay, guys, I won't say you again.
Okay.
Till whatever I have taught, you have to complete it. That's all. Thank you.